In this video, we're going to be doing factoring by completing the square. So first, I want you to observe that if we have a perfect square, suppose we have x plus a squared, x plus a squared, then we'll have x plus a times x plus a. And then we have x squared plus ax plus a squared. And then we'll have x squared plus 2ax plus a squared. So now, if we took half of the middle, so this would be our b term. If we took 2a and divided by 2, we'd get a. And then if we squared it, we'd get this n term, right? And then we started with x plus a squared. So again, half of that middle term with the sign that's here goes here, right? So half of the middle term, the b term, half of that with whatever sign that's in front of the b term. And that's squared. Okay, so let's go through the procedure. So if we have ax squared plus bx plus c, here we want a to equal to 1. And then the first step that we're going to do, we're going to take b divided by 2, then take the b over 2, square it, and then that b over 2 squared is added to the first two terms. So these first two terms we can put this into parentheses, ax squared plus bx, and then we'll add in that b over 2 squared, and then to the c, we'll subtract, from c we'll subtract b over 2 squared to keep the equation being true. All right, so let's look at an example. So for example, if we have x squared plus 8x plus 40. So here we see a is equal to 1. And so we could say we want to isolate those first two terms, put 40 at the back there. So now if we took 8, take 8 and divide it by 2, that would be 4, and if we squared 4, we get 16. So we add 16 here. So now if I'm adding 16, I have to take back out the 16 that I added. And here we have the completed square. So open parenthesis, x plus, the sign for the b is plus, and half of 8 is 4 squared. So x plus 4 squared would represent the x squared plus 8x plus 16. And then we have 40 minus 16, which is 24. So plus 24. Okay? So that's how we complete the square for this first example. Okay, let's look at another example. Here we have x squared minus 10x plus 4. So here, half of 10 is 5. So even though it has a minus sign, when we divide by 2, we have minus 5. But when we square minus 5, it becomes plus 25. So we're going to add in plus 25 here. We have plus 4, so we have to compensate for adding in 25. So subtract 25. So here we've completed a square. So we have x, and then there's a minus sign, and then half of 10 is 5. So x minus 5 squared represents x squared minus 10x plus 25. And then we have 4 minus 25, so we have minus 21. Okay, that's it for that example. Let's look at another example. So here, suppose we had x squared plus 5x plus 20. So we have x squared plus 5x separating the first two terms. And then we have plus 20. So now if we have 5, we divide that by 2. That's 5 over 2. So now if we square 5 over 2, we would get 25 over 4. So add 25 over 4 here. But then over here we have to subtract 25 over 4. So here now, this will be x. There's a plus sign. And then half of 5 is 5 over 2 squared. And then we want to do that subtraction. So this is plus. This would be 80 over 4 minus 25 over 4. So we have x plus 5 over 2 squared plus so this would be 55 over 4. Okay, let's look at one last example. So what happens when the a term is not equal to 1? So let's look at that. So suppose we add 4x squared plus 16x plus 11. So if we look at the first two terms, so we don't want the a term to be, we don't want the a term to be 4, we want it to be 1. So we're going to factor out the 4. So factor out the 4. So we'll have x squared plus 4x. And now we take half of 4, which gives us 2, and then 2 squared is 4. So we're adding 4 here, but we got to be careful. There's a 4 on the outside. So in actuality, 4 times 4 is 16. We actually added in 16, so we have to subtract back out 16. So keeping the 4 on the outside, we've completed the square. So x plus 2 squared, and then 11 minus 16 minus 5. Okay, that's it for this video. Thank you for watching.